Today we're going to talk about solving rational inequalities and also finding the degree given a table. If a is a real root of a polynomial function p, then the graph of y equals p of x has an x-intercept at the point a comma 0. Consequently, real zeros of polynomials can be endpoints for intervals satisfying polynomial inequalities. You can solve inequalities involving polynomials using both algebraic and graphical techniques. Let's explore some common connections between inequalities and the positive and negative sign of the expression. So here we have a graph. So when we write f of x, we're referring to the y value on the graph of f of x. So f of x is greater than 0 means that the graph of f of x is above the x-axis. F of x is less than 0 means the graph of f of x is below the x-axis. So consider the function f of x above. It says, where does f of x equal 0? So we can see f of x equals 0 at -3, -1, and 3. Where is f of x greater than 0? And notice this is not equal. So when we write our interval for greater than 0, we're looking at above the x-axis, which would be these places right here that I just highlighted. So we can write this using intervals with the x values. So this would be -3 to -1 parenthesis. And again, I'm not using a bracket here because it's not equal to 0. And at -3 and 1, those are the x-intercepts where it is equal to 0. And also from 3 to infinity. So that gives us our places where f of x is greater than 0. Now it says, where is f of x less than or equal to 0? So here we can use those intercepts on our interval. So that's where I just highlighted right there in the graph is less than. So from -infinity to -3, bracket, union, bracket, -1 to 3, bracket. All right, so that's what it would look like when we are graphically looking at our equation. So next we're going to talk about looking at it or thinking about the equation algebraically. So it says, let f of x equal x plus 3 times x minus 4 squared. Determine the real number of values of x that cause f of x to be 0. So when we're looking at the places where it's 0, remember we're just solving each of the factors. So x plus 3 equals 0. So x equals -3. And x minus 4 equals 0. So x equals 4. So those are the zeros of the equation. We've talked about finding those already in this unit. So now it says for b, where it's positive, so we're going to do f of x is greater than 0. And for negative, we'll do f of x is less than 0. So how do we do this algebraically when we don't have a graph? We use a number line to help us, and we're going to test the signs. So on our number line, we're going to put our zeros, which are -3 and 4, and always put them in order of the number line. So I'm going to put a closed circle on -3 and 4 because that's just where we're equal to 0. So I'm just going to make a note at x equals -3, the graph y value is equal to 0. And at x equals 4, the y value, again, is equal to 0. So not undefined, but just 0 here. So then when we're testing our numbers, just kind of like when we're finding the domain, we're going to test 3 different places here because we have three different spots. We want to test below -3. So when x equals, let's say, -4, I'm going to plug it into my equation, and I'm just going to look at the sign. So I don't always look at exactly what the value is. So I have -4 plus 3. And -4 minus 4 squared. So -4 plus 3 is going to be a negative number. And this is a negative number, but we're squaring it. So that means that's going to end up being positive. So a negative times a positive number is going to give us a negative answer. So that means this part of my graph is going to be negative. Looking at then in between -3 and 4, a number in between -3 and 4 would be 0. So let's test x equals 0. So in my function, I would have 0 plus 3 times 0 minus 4 quantity squared. So this gives us a positive, and this is also going to be positive, so that means these are going to be positive answers. And then above 4 would be a number such as 5. So then if we plug in 5, we get 5 plus 3, and then 5 minus 4 squared. So this is positive times a positive, which equals a positive. This means that if we were to graph this, that from negative infinity to negative 3 is going to be negative y values, and then from negative 3 to infinity, we're going to have positive y values. But again, we're only going to look for things that are greater than 0 for this first one that's positive. We're not doing equal. So if I want values that are positive, I have parenthesis negative 3 to 4 parenthesis union parenthesis 4 to infinity. And again, I can't just write from negative 3 to infinity because at negative 3 and 4, we are equal to 0. And this is just saying f of x is greater than 0. So you have to be careful about that. And then it says, where are we negative or less than 0? So we are negative from negative infinity to negative 3. And again, it's going to be using a parenthesis because at negative 3, we are equal. So that's how we would use the number line, but we can also think about this graphically. We've been graphing these polynomial equations, so we know that we have a 0 at negative 3 and at 4. And then we can figure out the end behavior because the polynomial degree, if we were add up the multiplicities, would be 3. So that's odd. And the leading coefficient would be positive. So odd positive, remember, means that the left end goes down and the right end goes up. And then one other piece of information that I always like to find is the y-intercept. So if we want to find the y-intercept, we plug 0 in for x and solve. So we already kind of did that right here. So we would get 3 times negative 4 quantity squared. So that gives us 3 times 16, which would give us 48. So our y-intercept is 0.48, which should be somewhere way up here. I'm just going to put that there. So then I can draw my graph. So we know the left end goes down and the right end goes up. So that means this goes down. We have to cross through our y-intercept to get to the next intercept. And at 4, it's multiplicity of 2, so we know it's going to bounce. So this is just a rough sketch of my graph. And again, then you can see that we were negative here. And then on the next portion of our graph from here to infinity, we were positive. So again, you can look at this algebraically or graphically, and we're gonna be practicing this number assigned to do it algebraically without our calculator. But again, you can think about it kind of like this. So when we're solving nonlinear inequalities or polynomials, we're going to first make sure f of x is equal to 0, and we're going to solve that to find the zeros. We're going to create a sign chart with the solutions from step 1, test the values on each interval to see if the values are positive or negative. And then we're going to interpret the sign chart to answer the given inequality for the problem. And then be sure to write your answer in interval notation and think about your endpoints. So for this first one, we have x cubed minus 4x is less than or equal to 4x squared minus 16. So the first thing I'm going to do is set this equal to 0, and it doesn't matter which side you use, but I'm going to take all the stuff from the right side and put it on the left side. So we would get x cubed, and I'm going to put it in standard form, so I'm going to be subtracting 4x squared to this side. So minus 4x squared minus 4x, because that was right here already, and then I'm going to add the 16 to the other side. So then I would get plus 16 is less than or equal to 0. So the next step is to find the zeros. So we're going to have to factor this. We can do factor by grouping. So then that becomes x squared times x minus 4. And over here we can take out negative 4, and that becomes x minus 4. And then factor by grouping, we group the first two terms and the other two terms together. And then x squared minus 4 is the difference of two squares, so that becomes x plus 2 times x minus 2 times x minus 4. which is less than or equal to 0. So we know then our critical values are the 0. So this would be x equals -2 for the first one. When we set it equal to 0 and solve, we would get 2, and then here we would get 4. So x equals -2, 2, and 4. So let's go ahead and put this on our sign chart. So on our sign chart, we have -2, +2, and 4. And these are just closed circles because they just equal to 0, and we're allowed to have 0 in the numerator. And then we're going to do our test number. So we're going to test our values in each of the spots. So we want to test x equals -3 because that's below -2. And we're going to use our factored form when we're doing this because it's easier just to look at the sign. So I don't always plug in the values. I just like to look at the signs as I plug them in because it's a little bit faster. So if I have -3 plus 2, that's going to give me a negative number. -3 minus 2 is a negative number, and then -3 minus 4 is also a negative number. Negative times negative is positive, times another negative would give me a negative answer. If I test in between -2 and 2, I would test 0. So if I test 0, I get 0 plus 2, which is positive, 0 minus 2 is negative, and 0 minus 4 is negative. So positive times a negative gives me a positive answer. And then in between 2 and 4, I would test 1. So if I plug 1 into my equation, I get 1 plus 2 is positive, 1 minus 2 is negative, and 1 minus 4 is negative. So that means this is also going to be a positive answer. And then if I do x equals 5, because that's above 4 at my 0, so that would give me 5 plus 2 is positive, 5 minus 2 is positive, and 5 minus 4 is positive, so that is also positive. For that. And I just noticed that I did x equals 1. Sorry about that, because that's not in between 2 and 4. So just kidding. Let's erase that and we'll put 3. Sorry about that. So then let's see, 3 plus 2 is positive, and then 3 minus 2 is positive, and 3 minus 4 is negative. So that actually gives us a negative there. Sorry about that. So we want the values that are less than or equal to 0. So where do I get less than or equal to? Here and here on my number line. So then my solutions would be -infinity to -2, bracket, union, bracket, 2 to 4. And here we're including those points because it can be equal to 0 because it's, again, less than or equal to for the symbol. So let's think about this graphically. So if we think about this graphically, the degree is 3, which is odd, and the leading coefficient is positive. So the left end goes down, the right end goes up. Our y-intercept, if we plug 0 in for x, we would get 16 out. So we have -2, 2, and 4. And so the graph will cross through here, and then you'll notice that it is crossing at 2 and at 4. So this is just a sketch of our graph. And again, we're looking for where the values are negative. So here and here. All right, let's do 2 more examples. So this is already factored, so that makes it nice and easy. We just need to find our critical points or our zeros. So that would be 3, -1, and -4. So on my number line, -4, -1, and 3. You always want to put those in order of the number line. So we're going to test x equals -5. And again, we're just looking at the sign. So -5 minus 3 is negative. -5 plus 1 is negative. And -5 plus 4 is negative. So negative times negative is positive times another one is negative. So if I do x equals something in between -1 and -4 would be -2. So -2 minus 3 would be negative. -2 plus 1 is negative, and -2 plus 4 is positive. So negative times negative is positive times another positive gives us a positive answer. If I do x equals in between -1 and 3, I could do x equals 0. So that would be 0 minus 3 is negative, 0 plus 1 is positive, and 0 plus 4 is positive. So this gives me a negative answer. And then x equals, let's do 4. So 4 minus 3 is positive, 4 plus 1 is positive, and 4 plus 4 is positive. So that's going to give me a positive answer. So then we're looking for where our values are just greater than 0. So here and here, but because it's not equal, we're not going to use brackets. So parenthesis -4 to -1 union, parenthesis 3 to infinity. All right, looking at the next example. So we have x equals -2 and 5 are our critical points. Those are the zeros of the graph. So -2 and 5, put our closed circles here because we could be equal to 0 in the numerator. And then so we're going to do our test numbers. We have x equals, let's do -3. So -3 plus 2 is negative, but we're squaring it, so that's positive. And negative 3 minus 5 is negative, so this is going to give us a negative solution. And in between -2 and 5 would be 0. So 0 plus 2 squared is going to be positive. 0 minus 5 is negative. And so that's going to give us a negative answer. And then x equals 6. We have 6 plus 2 squared is positive. 6 minus 5 is positive, so that is positive. And we want values that are less than or equal to 0. So less than or equal to 0, because we can be equal to, we can just say that this is the interval from -infinity to 5 bracket. And that's how we use our sign line. And then again, you could always think about doing this graphically to kind of confirm. So the next part we want to look at is determining the degree of a polynomial given a table of values. If a table of values with equal with input intervals, we can determine the degree of a polynomial by examining successive differences in the output values. The number of successive differences needed for the differences to be constant is equal to the degree n of the polynomial. So remember that the key here is that the table values have to have equal with input intervals. So like if one was going by 1 and then it skipped all the way to like 13, you'd have to be careful about subtracting those values, because here, notice we're going from 1 to 3, so that's a difference of 2, and then 3 plus 2 gives us 5, 7, 9. So since those are equal, we can go ahead and subtract to find the differences. So when you're subtracting, you have -3 minus -2. So -3 minus -2 is -3 plus 2. So you're subtracting them, and that gives us -1. And then here we have -1 minus -3. So again, minus minus becomes plus, so that's equal to 2. And then 4 minus 1 gives us, 4 minus -1 gives us 5. And then 12 minus 4 gives us 8. And then when we subtract again, 2 minus -1 is 3. 5 minus 2 is 3. And 8 minus 5 is 3. So this is a degree of 2, because the second differences are constant. So over here we have 0, 3, 6, 9, 12. So again, they're equal with intervals for the inputs. So we can go ahead and subtract. So we have 0 minus -2 would be 2. 10 minus 0 is 10. 27 minus 10 is 17. And 50 minus 27 is 23. And then we're going to subtract again. 10 minus 2 is 8. 17 minus 10 is 7. 23 minus 17 is 6. So then subtract again. 7 minus 8 is -1. 6 minus 7 is -1. So that means this is going to be a degree 3, because the third difference is constant. And that's how we use a table to determine the degree of the polynomial. All right, the last one we're going to look at is an application. So this says a ball is thrown vertically upward from the top of a 190-foot building. The distance above the ground can be modeled by this equation S of t right here, where t is measured in seconds. During what time period will the ball's height exceed that of the tower? So we're trying to figure out, so we have some tower here, which is 190 feet above ground. And so we're throwing a ball vertically, right? And we're trying to figure out when the distance, during what time period will the ball's height exceed that of the tower. So that means above 190. So we're going to take our equation, negative 16t squared plus 96t plus 190, and we want this to be greater than 190. So we're going to solve the inequality. So I'm going to set it equal to 0 first by subtracting 190. So that gives us negative 16t squared plus 96t is greater than 0. And then we can factor out our greatest common factor, which is the negative 16t. So then that would give us t minus 6. So then negative 16t, set that equal to 0 to solve. So you get t equals 0 and t minus 6 equals 0. So t equals 6. So on my number line, I have 0 and 6, and these are closed circles. And I'm going to do my test number. So let's test something below 0 being negative 1. So if I plug in negative 1, I get negative 16 times negative 1 is positive number, and then negative 1 minus 6 is a negative number, and that gives me a negative answer here. And so then if I do x equals something in between 0 and 6, such as 1, I get negative 16 times 1, which is negative, and negative, or 1 minus 6 is negative, so that's going to be positive. And x equals 7. So 16 negative times 7 would be negative, and 7 minus 6 is positive, so that is negative. Oops. And so we're looking for when the function, because this is the function, so we want f of x to be greater than 0. So where is it greater than 0? In between 0 and 6. So we could say the ball is above 190 feet on the interval for time. And you could write this as an inequality, so 0 is less than t, which is less than 6. Or you could say for time from 0 to 6 seconds. And so that means here, this would be at 0, 190, and that means this point right here is going to be 6, 190. And so where is the graph going to be above 190 in between those two values? All right, so that is it for our polynomials, inequalities, and finding the degree given a table in our application problem.